Hi, I'm Josh,
And I'm Blake.
and we are mentors on the 5026 Tesla Coils. I'm actually the head mentor, and Blake is the main builder. In fact, most of the time he's the only builder. So we're going to talk today about how to put together a linear slide system. We're actually going to show two different systems. One from the 5026 robot that competed in Cascade Effect and went to Worlds. And then Blake introduced this robot.
So this is the robot that we had for this past year, the Vortex Velocity season. It also made it to Worlds too.
That's Velocity Vortex, but it's okay. He's Russian, so he mixes up his words sometimes. So we're going to talk really quickly about how we put this slide together. So focus on this robot for just a minute. And you can see that what we used is we used the Bishop Wise Carver bearings. They're so they have a bearing inside, and then they're just really, really smooth. They only cost about, I think they cost $2.56, something like that. So they're actually really inexpensive. We used Kevlar harpooning line. You can find on Amazon for cheap. And the reason that we use Kevlar rather than nylon is that the Kevlar doesn't stretch. So when we originally went with this system, we used nylon, and our string never kept the same tension, and was always a problem. We'd always start losing our string, and we figured out that if you use Kevlar, you won't have that problem. A couple other features of this slide before we show it. On the linear slides, Matt, can you go up really quick? Oh, it doesn't stay up. Okay, go up. Go up. Okay. So on the linear slides, what we decided to do was to take apart the slide. And it's really easy to do. These are just drawer slides from Home Depot. And what we did was we actually took them apart and bolted on a nut, welded on a nut that we could bolt the pulley to. So if you can get a close up here of the weld mark, you can just see that it's bolted on. We put a nut on the inside to give it some spacing. You can see the difference in spacing that we used throughout the system so that everything meshed well together and we didn't have any binding problems. Okay, go back down. And then the other thing that we did, if you look down in the guts here, we did a 2-motor system because we needed lots of strength. We had to get the balls up to the center really quickly and into the tubes, and so we wanted a really quick slide, so we have some gearing. We changed the gear ratio to go up faster, and then we also put in a system where just a reverse winch system so that we weren't relying only on gravity to bring the slides back down. We have it controlled. So Matt is going to flip the switch and demonstrate how this system works. Going up. Okay, hold it all the way up to the top for a sec. Okay, so you can see that it goes up. We can keep it held up without burning any motors. And that it comes down really quickly, but when it comes down, we're not unthreading all of the pulleys because we have to go up and down multiple times in the match. And so, Matt, you want to run it again just for fun? All the way up, all the way down.
What's the
So, I'm sorry?
The spring.
So the spring, the whole reason that we have this block in the spring is to keep this line always tensioned. So when we first put it without the spring, we'd still lose a lot of the tension. Basically, we would put the spring in with the block, so at a point it tensions everything. You can see it tension the spring, and so we're just keeping tension the whole time on the whole system. That's what keeps it controlled, so that we're controlled all the way up to the top and bring it back down completely controlled instead of relying on any gravity. In this case, gravity was not our friend. Thank you, Matt. The only other thing that I'll say about this one is that we definitely linear slides with bearings, or pulleys with bearings, definitely more valuable than just trying to have something running over a rod. There's so much friction, and to be able to have the speed that you want and the control, you need those bearings in there. I think that's all for this robot. So I'm gonna pass this over to Blake. He's gonna talk about this year's world-class robot.
Yeah, so can we get the controls on over here so that we can run it up and down? So this one's a little different than the other one. Instead of having linear slides, we have this 80-20 rail, and they actually have, I don't remember what kind of plastic.
It was just a Teflon bearing.
So we just have some Teflon rails that can fit in between. It fits nice. If you look right there, it fits nice in those rails, so that it works as a pretty good. I think the string just came over. That's convenient. So that it just sits right in our building material instead of having to use just normal slides. So if they run it up real fast. So we have the same design of the pulleys with the bearing inside, so it just kind of loops around and up and back down to the bottom, and that's how it pulls it up, because when the string gets pulled, it pulls the two bearings closer together. So the way that we actually have this mounted, we have two different ways that we've mounted the slides into the 80-20. We have some little set screws that we just have clamped together. Then this one's actually just kind of in between there. We have a little cap screw up top so that it doesn't slide down right there, that holds that in place. And then if you look on this one, there's some other slides where we've just cut out part of the railing and then bolted it straight to the rail. This works pretty good. It just sometimes has a tendency to bend because there's these little spots and then it can get caught. Whereas this one, if you look, the slides all the way through. Yeah, it's completely solid. So then if we bring it back around to the other side where we have our tensioner right here, we have a little bit bigger spring than the other one. So what we did is we just put another one of our little pulleys on just a smaller piece of the Teflon. It can just go up and down, so this keeps it as a constant pressure as we drop it back down so that the strings don't come unwound. Then we have I think it's a 49-to-1 gear ratio gearbox down there, which allows us to keep it pretty fast. Kind of hard to see, it's this big black block right here. I don't remember, what are the gearboxes called?
Vex.
So there's Vex gearboxes.
Yeah, they're Vex Pros.
Vex Pros. So they allow us to kind of create whatever gear ratio we want, because the Andy marks only come in the 20, 40, and 60. So we wanted somewhere between the 40 and 60 so that we still had the strength but a little bit more speed with it. So we have it there, then we just have a nice big, I guess it's a wheel that'll just twist around when we want it to go up and down. So if Matt wants to run it again real fast. This one also differs from that one in a little bit because that one has the two sets of rails that are together. If you want to pan that to it real fast. So it actually has two sets of railing with a centerpiece in between, whereas this one, it just kind of builds around in a J shape. So if you look up top, we have this bar, which is stationary, then this one builds off of it, that one builds off of this one off of that one, and so on. So Matt, run it just a little bit real fast.
Don't stab me.
So the first one will lift up and then go to, then the second one, and the third, and they just kind of all slide out. So it's a little different. It's a little different than the other one because it has just the one set, which makes it able to be more compact, but it doesn't quite have the rigidity because I feel like it has a little bit of wobble to it, whereas this one
Is more solid.
is just kind of solid, yeah.
Solid or
Solid. If you want to use good English.
Good?
how are you?
All
while we were talking is the reason that we went with the double slide arrangement here is primarily because, oh, thank you, the compressor finally went off. So the reason that we doubled these up is primarily because where this is a recycled component, we had to keep going up and down constantly. We really needed this to be as stable as possible, and if you've ever played with these drawer slides, one slide just has a lot of wobble, a lot of play on it. Two slides, there's hardly any play at all. This thing went up and down thousands of times during matches and practices, and we competed really well at Worlds with it. So I would recommend anytime that you use linear drawer slides that you double them up for strength.
And if you're going to have multiple.
And if you have multiple revolutions. This robot over here, you really didn't need that because the only reason for the lift was the end game, the capping the cap ball. And so it was a one time we needed to get up really fast, cap the ball, and basically be done with the match, go hit a couple more beacons if we needed to. But it was just a one-time use thing for this season's game. So I don't have anything much else to say about the lifts. Do you?
Nope. I think we covered most.
I will say that in the year before Cascade Effect, which I can't remember what the game was.
Block party?
Huh?
Block party.
Block Party, we used the exact same lift mechanism, or at least a very similar lift mechanism. And this mechanism, we were able to lift up, grab the bar, and hang on the bar. And we had just as fast as a lift and get us off the ground and up to the top of the bar, or the bottom of the bar, I guess, just as fast as you saw it here. And then it would lift the robot up with as much strength. So this is a very solid system that we got to give credit where credit's due. Our main builder, Troy Dusnip, from 3 years ago, built this system, and it just performed amazing. So with that, I think we'll end. Thank you, Blake. It's been fun.